Thanks for having me. And thanks, everyone, for logging in and listening to me speak for the next hour. So I'll just jump right into this. Hopefully everyone can see my first slide for my intro to HTML5 gaming with impact. And just kind of a quick summary, this talk is going to be about HTML5 gaming in general, but really using a framework called Impact.js. And I'll go over some reasons of, why I chose Impact over other open source game frameworks. I'll go through the framework itself, and then I'll talk briefly about some games I've been building with it and kind of the things I've been learning through it. So to get started, I'll just do an introduction to myself. So my name is Jesse Freeman. I am a technical architect and technology evangelist at a company in New York called Round Arch Isobar. We actually have offices all over the U.S., but if you cannot tell from my accent, I am situated in the New York one. My job really revolves around building enterprise apps. I'm an enterprise-level architect, and building games is something I do on my hobby. Just happened to be I wound up being very good at building enterprise apps, and if you hadn't seen my talk at Fluent, a big thing that I talk about is I use game development in everything that I do, especially in enterprise, and there's a lot that you can really learn from games such as optimization and performance and visuals that really you don't learn from other fields of computer science and development. So the way that I approach most of my development comes from a gaming background. So in my head, I like to think of everything as if this is a game and how I can, architect it in that way and try to keep things interesting, especially if I'm building something boring like a big financial app for a bank. So the other part of my job is doing technology evangelism. So I do a lot of talks. I have a link for my website. It's jessefreeman.com. But I think I did about 10 talks last year. I'm already up to about 4 or 5 this year. So I get around and basically talk about this year I'm really doing the HTML5 gaming, and I also talk about other platforms and stuff that I'm learning as well. So talk real quick about why to use Impact.js. I played around with a lot of the open source game frameworks that were out there for HTML5. HTML5 is the new buzzword, and really when it comes to game development, what we're really talking about in reference to HTML5 would be using stuff like Canvas and the audio tag, even some more lesser known APIs such as request animation frame and stuff in the browser that really is allowing us to replace plugins and offering us the same sort of high performance visuals that we were using with plugins, but wrapping it more around Canvas. Impact is a JavaScript game framework, and it really takes advantage of modern browsers' Canvas element like I was talking about in order to create these high-performance 2D games on the web and even on mobile. And as you get further and further along into learning more about HTML5 and especially Canvas, you can start doing stuff with hardware-accelerated Canvas, which is now coming into all these browsers. Impact is really geared towards 2D side-scrolling games, although there's a lot of people who are out there doing some pretty interesting things with the engine. But that being said, you can still get hardware acceleration, and the performance is actually quite incredible, even on mobile devices now. There are limitations, such as like on the iPad, you don't get audio through iOS, but I'm able to, on the latest iPad and the second generation iPad, get even 60 frames per second on my games. So the only barrier of entry when it comes to Impact is that there's a licensing fee. The program is, or the framework is actually not open source, and I know this kind of turns a lot of people off, but you kind of get what you pay for. And after you pay the licensing fee, which is $100, sometimes it goes on sale. Dominic is pretty good about trying to get people to get access to it. But you get the full source code, you get Weltmeister, which is the level editor, and then you get free updates until the next major release. So we're getting towards the end of one cycle of version 1. He's already working on version 2. But as he continues to patch and update the framework, you continue to get updates to the source code. And what's really powerful about Impact is that in addition to getting the source code, which if you're like me, I love seeing how things work, so I take apart all the source code. I spend a lot of time in the architecture understanding how it was actually built. But you also get a level editor, and I think the biggest barrier of entry if you're not a full-time game developer or you don't come from that background is having all the tools you need to actually build a game. So having a good framework that handles all the visuals for you and is easy to extend and build off of, and also have a level editor really goes a long way to making sure that you can actually get up and running. And it handles multi-touch support on mobile devices, and it really covers the gambit. So it's a very solid framework, and most of the other ones I've been looking at just weren't polished, and this one is incredibly polished. So some links, to get you started, if you've not actually been to the website yet, is impactjs.com is the main site. There's a forum as well, and the forum is very active, and there's a lot of people out there who are helping each other out, and you get a lot of good code examples from that. There's also a demos page that shows off games that people have been building. And then there's also the purchase, and I know for some people $100 might seem a lot for a framework, but like I said, it's worth every penny, and I wouldn't have spent so much of my own personal free time writing a book on it and talking about it at all these conferences if I didn't feel it was actually worth the money. So when it comes to getting started with Impact, there's just a few things that you need. One of the great things about Impact is that it has no IDE dependencies. So you can actually create your game with any simple text editor. I use WebStorm by JetBrains, which has like code hinting, project management, refactoring, debugging. It's hands down one of the best HTML editors out there. It's actually a scaled-down version of IntelliJ, which covers a much larger set of languages. But I definitely highly suggest checking out, and they do sales as well. I think it's in between $50 to $100 for that IDE. You can also just use a basic text editor or Sublime Edit or whatever you prefer to use. Then you're also going to need Apache just really for locally hosting and testing your games. You can use other servers, and I'll kind of talk about other server solutions, but Apache is pretty much what it expects out of the box. And then you're only going to need PHP for just saving levels from Weltmeister. So one of the things about the level editor is that in order to get the file access, it just uses PHP, but you can actually swap out the APIs and you can write your own solutions. And there's a bunch of people who've been doing it. I'll cover a few other different languages that you can have it save out to. And then the last thing is going to be the browser. You're going to want to use a modern web browser. It works very well in WebKit browsers, especially Chrome, but any browser that supports Canvas should work as well, and audio. So for anyone who's not familiar with WebStorm, you can get it at jetbrains.com, and they have a 30-day trial. It's a little bit of a learning curve if you don't come from a large kind of Java-centric IDE, but once you kind of get used to the workflow, it's really worth the time learning the program. The other part, talk real brief about setting up Apache and PHP if you have not already done that on your own local test device. So I used to go through and do this all by hand because I liked punishing myself, and I'm a big fan of knowing how to compile this stuff from the command line, but it also becomes tedious when you have several different computers. So when it comes to the Mac, even though it is built in, it's sometimes a little bit of a pain in the butt to actually configure. So I just tend to now just use MAMP, which is a really good all-in-one solution. So you just install MAMP, you click go, you point to the directory of where you want to have your server's root, and it'll host everything for you. And one of the things I do is I keep all of my stuff in Dropbox. So all my development is done in Dropbox, and then I point MAMP to the root of my Dropbox development folder, and then I can just go through any project. So if I'm working in Xcode or if I'm working in anything, basically I can just have access to the server. If you're on the PC, there is a really good alternative called XAMPP. XAMPP is the same thing. It's just a one-click solution for a kind of LAMP stack. It gives you Apache, PHP, and MySQL. And then the same thing on the PC. I just configure the htconfig to point to my Dropbox dev folder, and then from there I can just browse anything as I'm doing my development. And then there's some other hosting options. There is a Node.js version that you can try out by Connor Petzold. And his JS module just allow you to run everything through Node.js, which is actually kind of interesting. And lately I've been doing a lot more with Node.js for even my build scripts and automation. So that's kind of something that you might want to try checking out. And I think that, in the future, also if you're doing like multiplayer games, it's interesting to actually run Impact on Node.js and then create clients that are simply viewing the game graphics so you can deal with security better. So I think Node.js is going to become really critical in HTML5 gaming is it starts to evolve as a really stable server platform. There's also a .NET solution, and then there's also a Ruby solution, and all of this stuff is kind of outlined on the Impact.js site, and I also go over this a little bit in my book, which I'll bring up towards the end. So if Ruby is more your thing, you can use Ruby and .NET. So I'll talk real brief about setting up Impact. Once you purchase a license for Impact, you're going to get basically all the source code. You're going to get some example projects, and then you'll just get some bits and pieces here and there for helping you set up different types of entities and just a few structural things just to get set up. So all you do is copy over your Impact folder to your server and then hit it from localhost, and you'll see it works, and then your game is ready to go. And then from there, you can just go in and start building out all your game logic. So it couldn't be any easier to set up. So one of the things that you'll see when you start looking through the Impact folder itself is that there's 5 main parts to it. The first is the index.html, and this is what really hosts your game. When you look inside of it, there's, it's a really simple HTML file. It just has 2 references, one to the Impact game framework JavaScript library. The other has a reference to your to where your game code lives, and then in the lib folder is where all the actual framework lives. So inside of that is where you start putting all of your JavaScript code. And then you'll have a media folder. In the media folder, what you'll have is that's where all your graphics and artwork go. There's a tools folder, and this contains some scripts for allowing you to kind of compress and obscure your game. To be fair up front, it's JavaScript. It's incredibly easy to decompile this stuff because it's not really compiled. So all the compression script does is it takes all the different JavaScript files that you create for your game, puts it into one big massive script, and then it just removes all the white space. So it's not really doing a lot of crazy obscuring. But so you should keep that in mind, like I was talking about using Node.js. If you're building a game that you don't want people to be able to hack into, you need to look into other solutions for hosting it. Impact doesn't really cover any of that kind of security. But this also helps when you're trying to distribute it, because now you can distribute all of your JavaScript code in one single file. And then the last thing to bring up is the Weltmeister HTML page, which is the level editor itself. So, and I see questions are starting to come in, so I'll get to questions towards the end of the talk. So when we look at the architecture of Impact, I come from really strongly typed class languages, so things like Java and ActionScript and C#, and I really was not very happy to sort of go back to JavaScript because you can just kind of do anything you want and there's not a lot of structure to it. One of the things I found really refreshing is that Impact has some very interesting ways of organizing code that resemble packages and having its own kind of class structure. And while I'm not a big proponent of modifying languages to be something that they're not, I think Impact plays very well off of the object-oriented nature of other languages by giving you these kind of base classes. So you don't have to go and reinvent the wheel. The biggest part is definitely the modules, because what we get from other languages is the ability to have one class dependent on another and make sure that they load in the correct order. So when we look at modules in Impact, this basically implements the kind of include function you'd see in other languages. And this really is powerful because it allows you, one, to only bring in the classes you need for your game, so that when you compile or when you run the script to bake them, you only get the bare minimum you need. And then also you can create a hierarchy to the order of how things are supposed to be loaded in. So if one script needs to modify the main game engine, you can load that before anything else, and then you can start executing your code. It does use a custom module kind of setup, and it's not that much different than most other systems I've seen, but you'll see that classes in most part are set up almost like JSON and just straight objects in the class file. So this is just an example of a module, and as you can see here, go through these slides. So the first part is you attach the module itself to the IG namespace. That's where the game lives. and there is you give it a name. So in this case, it's game.myfile. The next block is a requires block, and this is kind of what I was talking about. So you can pull in parts of the framework ahead of other parts so that you can actually, create a really good control over the order of how things are modified in the game engine. So in this case, you can say, load in impact game, load in the impact image, and then any other game files you have. And the way that this works, if you remember back to the slide I was talking about with the structure of the project, this is actually the directory structure. So in this case, all the code lives inside of lib, and for the game, it's lib impact game is the actual name of that class. So this will just load up, or that module, it'll load up that module. So your code lives inside of the lib folder under game, and then you can load in your own custom game logic. And the last part is this defines block. This is where we actually start putting in our classes. But what's really cool about the defines block is that you can also have it execute code in there as well. So you don't have to think in this limited way of that you can only put classes in there. I actually do a lot of just regular, JavaScript that would manipulate the DOM or, tweak parts of the game framework itself. And I can put this, just anything that gets in here gets executed in a particular, order, just like you would have JavaScript on the page. And that kind of brings me to classes because, if you put all your logic in the defines block, it's actually just going to execute as soon as that module is loaded. So the way that we get around that is by defining classes in Impact. And classes in Impact are based on John Resig's simple JavaScript inheritance code. And this is just a very, simplified version of what a class really is. But it offers up probably the most important thing about object-oriented programming, which is the notion and the ability to extend. And one thing that Impact does is it allows you to extend other objects or classes with deep copying of properties. And also it allows you to do static instantiation, which is really key in games because there's a lot of subsystems where you only want one instance of that. So creating classes is pretty straightforward. Again, this all goes in that define block that I talked about earlier in the module. And we just simply give a class a name, so var person. And then what we do is we actually talk to the class itself. So IG class. In Impact, there is a class for class. And you just call extend on that, and that will copy over all the functionality of class into your person object. And then from there, if you're familiar with this type of programming in other languages with classes, you'll see that you can just add properties to the top of your class just like you would anywhere else. The only difference is that, we're doing this in kind of like a JSON type format, or object format as well. So you give it, its name for the property, and then its value with a colon, and you use commas to separate each property and each method from the next method. And that'll be like a big, kind of pain point if you're not familiar with this paradigm of programming, is as you're going through, and something just crashes or there's an error, it's usually because I forget to put a comma. I still put semicolons in by accident. So, one thing to think of is when you see this in multiple functions that you want to have the comma separating it. And WebStorm is actually really good about telling you where those errors will be. So another reason why to use an IDE with a code editor that also gives you error correction. This last example here shows you just a basic function. So again, you just give the function a name, you define the function next to it, and you can also accept parameters. Then here I'm just showing off an example how we're accepting an argument called name, and we're passing it up to the name property, and you just have to use this namespace because everything is scoped into the actual class itself. And then from there, it should be pretty straightforward. You can just create a new instance of that class whenever you want by just using the new constructor. And then if you trace out the property of name, you're going to get name. So the other thing that this also allows us to do is extend classes. And there's a lot of debate over, composition versus extension in game engines. There are a lot of cases where you want to use extension. And there are some very interesting things in Impact, which unfortunately I probably won't have time to get into, that allow you to inject code into other classes so you can do sort of pseudo mix-ins on the fly. But the primary way that you're going to be working with classes is just by extending. So just as I showed the original example of extending class directly, in this case here we're creating a ninja, and the ninja is just going to extend the custom class we wrote, which was person, again, extend, and what the extending allows you to do inside of Impact is you now have access to this .parent, and you can pass parameters back up to methods that you are extending. And init, by the way, acts as the constructor. So whenever this class gets instantiated, init is the first method that gets called. So here we're just appending the word ninja to any name that's passed in. We pass that up to the parent, and now when we create a new ninja and we pass in a person's name, every ninja class that we have will have ninja in front of it when we trace out the name. So this is pretty kind of standard stuff, but it's just a little bit different in Impact, and once you get around this, everything else is a little bit more straightforward. So I'll take the next block of time to kind of just go over the core classes of the framework. I'm not going to show any code. I think that there's a few key things to go over, especially when you're learning a framework. You want to get like this high-level overview of all the classes. And you would think that a game framework would be made up of tons and tons of classes, but this framework is actually incredibly concise. I think there's about 10 to 12 different classes that represent the entire game framework. And then once you kind of see this, you'll have a better sense of, as you go through code examples and you see, this class is instantiated here, you're like, oh, okay, I remember that class. This is how to use it. So the main part of Impact all resides in this IG object. So IG is the namespace for where Impact attaches all of its modules, all of its classes, and the core class itself, when that gets instantiated, it just attaches the global, everything you need to basically run the game engine. And so this will just modify the global namespace, and then you can access everything after that from IG dot whatever you want to get access to. So a big part of what the game framework does for you is it handles animation. So animation is done through sprites, and I'll talk a little bit about sprite sheet and that kind of workflow. But there's an animation class which will handle all this for you, so you don't have to deal with any of that animation at all. And I'm going to go through this stuff kind of quickly because this is all on the website, and if you do purchase a copy of my book, I go through this stuff in a little bit more detail. The next part is the animation sheet. So you can have a basic animation. The animation sheet is a wrapper for the image class, and this is what allows you to basically say, all right, I have a sprite with X number of frames, show frames 1 through 5 and loop them at this many seconds, and that's what handles that logic for you. There's also the notion of background map, and a background map is the actual class that just draws the 2D tile set to the display when you're doing your level. So in the level editor, you can paint out each of your tiles that make up your game, and then from there, the background map will handle, actually displaying that in your game. There's also a collision class, and this collision map class actually handles all the collision inside of the map. So when you go through and you paint tiles on the map, you'll also paint tiles that represent solid and, places where you can pass through. There's also slopes. So the game engine handles basic collision in the tile engine for your map. So this is also a very helpful class. You don't have to really think about it. It's just kind of built into the map. Entity is the main interactive object of your game. So if it moves or if it's displayed on the screen and it's not part of the map, chances are you will be extending entity. So your player, your bad guys, items you'll pick up in the game, these all extend entity. And entity is just a wrapper for, it allows you to do stuff like set up animations, and it has logic in for drawing all those animations in time with the game engine, and also handling some basic physics and collision detection. There's a font class. So right now fonts are kind of primitive in Impact. They're bitmap fonts, so you have to supply a sprite sheet that represents a font, and you don't get a lot of the control you'd think generally with other fonts, such as like kerning and stuff like that. It really is just for basic text. But the good thing about that being as bitmaps is that you can have any type of fancy text you want since it's just an image. The IG game class is the main class that actually runs all the interactive parts of your game. So your main class will actually extend the game class. And the way that I view games, these game classes, is as if they're screens in the game. So it's a little deceiving with the nomenclature of it because it says game, but really it's like you can extend game and make a start screen. It doesn't mean that a player has to run around and have a map. You can just hook into its draw function. And then from there, you can also have extend game to actually do your in-game, load a level up, and put the player in it. So game is kind of versatile, but this is really where the core of your logic for whatever activity you're in is going to be running. There's an image class. This is the primitive towards the animation and the entities and everything else. This primitive class basically wraps a PNG, a GIF, or a JPEG and allows you to draw that to the display. So you can just have, like, let's say you have a HUD or some sort of UI element. You can just load that up as an image without having to extend entity, and then just call draw on the image and give it an XY coordinate of where to draw. And then you can also draw a tile from it, so you can also have, you can make your own custom sprite sheet and just define regions that you want to draw from it, which is really helpful. There's also an input class. The input class handles all keyboard and mouse input. And the one thing that I don't really cover, which I should add to the slide, is the fact that it also handles touch events. So if you are in browsers that support touch, such as iOS and Android, it'll also take care of that for you. There's a loader class built into the game. One of the cool things about Impact is that it won't run your game until everything is actually loaded up. So if you think back to the requires block that I was talking about, Impact goes through and pre-processes all of the game files. And because of that, it's able to determine the load order for everything that needs to be in the game. And it also looks and parses out images as well and sounds. So it'll go through, load everything. It shows you a loading bar, and then once the whole game and all the assets are loaded, everything is ready to go. It enters into the main game that you define. The map class is just it's the composite of the background map and the collision map. So you can query the map for all kinds of data, like what is the next tile from where the player is, so you can tell if it's going to be a ledge and if he's going to fall off. And actually get access to, what specific tiles there are in case your guy goes into water. You want to make sure that, he moves a little bit slower or he floats. There's a music class. So, to be honest, audio tag in HTML5 is still kind of up in the air. Some browsers support it, some browsers don't. Impact does a very good job of making sure that it tries to support it where possible. This music class allows you to have background music, and you can set up a playlist, you can set up looping and play order. So this is kind of a singleton in the framework, and you can also set the volume independent of the rest of the sound of the game. The sound class actually represents a single file. So just like you have image where you'd point image to a graphic, you can create a new sound file pointed to either an MP3 or an OGG file, depending on the what browser you're using, and then it will automatically play that sound for you when you call play. And that's kind of key, and one of the reasons why it doesn't work so well on mobile is because you have to preload all the sounds so that they're ready instantaneously when you access them. So mobile browsers' audio support is very limited right now. It only has a single channel. And also, even in desktop browsers, there's limitations on the number of channels you can run simultaneously, but I haven't been having too many problems so far with Impact. So all of these are wrapped up in the Sound Manager, and the Sound Manager is what just manages the difference. You can actually, since you have to supply different sound files for each browser, like Firefox would use an OGG file, or Safari might use an MP3, you can just put an asterisk at the end of the sound name, and the Sound Manager will go out and detect the browser you're in and load the correct sound file, which is also really helpful. So, if anyone's actually had to deal with the audio tag directly in HTML5, it's a little bit of a pain. So Impact handles all that for you, which is super helpful. The system class is the main class that runs the game loop. So if you're not familiar with game engines, there's always a constant loop. You define the frame rate, and the system job is to make sure that the game is running at that frame rate or that it drops frames where possible. So this just handles that, and if you need to pause the game, you can call system and tell it to pause it. And it also has some utility methods for helping with setup input and other parts of the framework. And then the last class is the timer class. So, a big part of time-based animation versus frame-based animation is being able to keep consistent frame rate. So you want to always make sure that you have some sort of timer class that indicates the difference of time, because if a game is running at 60 frames a second on one computer and 20 frames a second on another computer, you want to make sure that you can account for that. And the timer allows you to do that by, you can call for the delta, which is the difference in time between the frames. You can see if your game is taking too long to execute, and you can make accommodations like say, all right, maybe skip a few frames. And a lot of this is kind of built into the game engine, so you don't have to think about it, but it really becomes important where if you're doing custom timers, like let's say your character is invincible for 2 seconds when the level loads up, you want to make sure that that 2 seconds is accurate and that it's not being messed up by the frame rate, so you can use the time class to handle that. So that was all of the game framework. It's a very small framework. There's a lot of code in there, but it's all very clean and compact. So it's not much to take in, and it's another plus about the game framework being so simple is that it's easy to pick up these things. So I'll talk next about the asset pipeline. And when it comes to building games, we refer to the asset pipeline as the visual workflow for your project. So it could be something as simple as copying files over by hand into your game's media folder, or you can write these like complex automation scripts to generate artwork for you, which is more what I tend to do. I like to have everything kind of automated so I don't have to keep updating things by hand. So the basic visual element in the game engine is a sprite, and a sprite is just a single bitmap image that's drawn to the display. So in this case, it's going to be our canvas element. And to help organize them better, sprites are usually grouped into these things called sprite sheets. Once you have a sprite sheet, it's really easy to set up an animation loop. So this is just a few examples from my player class. You would set up in the player class, you'd call this .add animation, and you would pass in a label so that you know how to access it. So this is idle. It's going to go for 1 second, and it's going to use sprite 0. So everything is 0-based, so the first sprite is always going to be 0. And as you see through these other sets of animation, you can call, I have run, I have jump, and I have fall. And then you can also make, multiple frames, and you can jump around the frames. It doesn't have to be linear in any fashion. So if you have a more, creative way of packaging up your sprites for optimization, don't worry about them being, in a consistent order. You can define that all by hand, which is incredibly helpful. The other part of using sprites is for maps, and we call these tile maps and tile sheets. So it's the same concept where you define basically the size of each sprite, and then you can paint them down. So here's a sample of just a level, sprites that make up one of the levels in my game, and how I was able to use the map editor to kind of lay it all out. So one of the things that I do, because I'm OCD about being as productive as possible, is I write lots and lots of scripts. And one of the coolest things about Photoshop is that you can actually automate almost every aspect of Photoshop. And even better is that you can do this all using JavaScript. So, if you do a Google search for Photoshop scripting, you'll be pretty surprised by how much access you get to Photoshop. And one of the most tedious tasks is actually building out sprites in your game. So one of the things that I do is, coming from kind of a traditional art background, is I used to do animation. I want to do layering. So I don't want to lay all of my sprites out, horizontally and then start editing them. I want to see them layer on top of each other so I can do transparency and test the animation out and test the walk cycle out. So I'll go through in Photoshop and I'll set up all of my sprites in layers. The actual PSD will be the size of the sprite in the end. So in this case, this guy is 16 by 16 pixels. So when I run my script, it's going to make, however many layers multiplied by the size of the canvas, it's going to make it that wide. So, here's kind of an example of what it outputs. So I put this script up on GitHub, and this is it's a very basic script. It doesn't loop down. It only just keeps going horizontally. I mean, in the end, it doesn't necessarily matter. But, what it'll do is you just run the script. It'll go through all your layers and then evenly lay out every character horizontally. And the key to having scripts like this, even the most basic script, is that if you're changing graphics a lot, you don't want to have to generate these things by hand. because it's very hard to lay them out and censor them in boxes manually, because then you get animations that are all jittery and jumpy. The one thing that I don't automate, though, is actually saving the files out. So you have to, think back when I was talking about the fact that Impact actually loads up all the graphics at once into memory. So you want to be, really careful about file size of images. Sound is usually the biggest problem in the game, but in this case, I go through and, every byte counts. So I'll look for the smallest file size. So in Photoshop, you can do save for web and devices, and I just go through and figure out whichever one is the smallest one. So I like to do this one by hand, especially when it comes to stuff that's like PNG 8 or GIF. I can go through and I can pull out particular colors and have the smallest color palette possible. And I'm looking at the time, so I'm going to kind of go through this stuff a little bit quicker. Another thing that is really important in Impact is collision detection. Impact's collision detection is bounding box-based, and what that means is that it's not doing pixel per pixel collision detection. It's just a box is drawn, or you actually define the box around your entity, and then it can test for when two boxes collide. This is the fastest type of collision possible in a game engine, and that's why Impact uses it this way. So it's not incredibly accurate, but it allows you to have very decent collision detection. And Impact really has a unique way of setting up collision. There are three main properties that handle collisions. And collision detection in Impact, you really want to think about it as you're setting up relationships as opposed to brute force trying to detect things. The engine will do a very good job of running through all of your entities as long as you set them up correctly and try to test them against each other. So the first property is one called type. And the way that Impact works is that you basically have two groups, or three technically. You have none, where it will ignore any type of collision detection altogether. You have type A, where it will go through and it will look for anything of type A. So in this case, type A would be good guys is usually how I consider it, and then type B is bad guys. And so you're going to want to have, if you have a player or you have a monster that's looking for the player, you want to have your monster set to type B, your player set to type A, and then from there, in the next property, where we look at check against, we tell our entities to look for each other. So the player is the one entity where you don't want it looking for anything. You want everything in the game world is against the player, and that kind of helps on optimization. So using these properties sparingly will also help build very performant games. So in this case, our bad guys are always going to be looking for entity type A. Bullets will always be looking for entity type B. And then you can have things like a grenade or some sort of platform that would crush something, and you can set that to both. So it's looking for the good guys and the bad guys, and it's going to kill, or collide with either one of them. And then the last one is the notion of collides. And collides is how we set up these basic physics relationships. So there's no Box 2D built into Impact. There is an example that comes with the game library that shows how to use Box 2D. But to kind of briefly go through these, you'll set up, each of your entities will have this collides property. And as we go through them real quick, there's this notion of active versus light or fixed versus any. And the way that it works is that they have kind of like a power situation. So a fixed platform is always going to be is always going to move weak platforms or weak entities. And there's a lot more documentation on this. This is just kind of a summary to get your head around it. But you go through and you can set up these type of relationships and see that if you want things that are passive, so like entities, for example, might walk through each other, but they still need to have some sort of notion of, of mass. You would set them to passive or light. And then anything that's passive or light, light is the weaker, passive will push it around. So as you see, for a second there, I thought I was going to go into the particles. But if you have particles set to light and you have a passive character, the passive character will move particles, or the particles will sit on the passive character. Then you get to situations like fixed versus fixed. So you'd always set like a platform to fixed. So you can't really have a scenario where you have two fixed things colliding with each other. But everything else, if anything like a light or a passive or an active entity stands on top or next to a fixed one, that fixed one will move it. So if you have the platform moving left or right or up and down, it'll push it out of the way. And then, yeah, here, as we talk about like particles and platforms, like I just kind of covered, usually you set particles to light if you want the particles to not be really affected by things in the world but sit on objects. So like let's say you have snow, you would set it to light. If you have particles that are just there for effects, you would set it to never so that they never, collide with anything. And then, like I said, platform should always be set to fixed. So that kind of covers just the basics of the collision detection, and then I'll just briefly talk about deployment. Impact supports a lot of different platforms, which is another reason why I really love this game framework. So, the most obvious one are going to be desktop browsers, so Chrome, Safari, Firefox, Internet Explorer 9. All the modern versions of these are supported. Then you get into mobile browsers, such as iOS and Chrome for Android. Chrome is on the weaker side. Chrome has a lot of problems around rendering canvas-based games, and Chrome for Android has a lot of problems with that. Android in particular is completely fragmented, as many people know. So, you're not going to get very good performance out of Android devices, and it's very difficult to test them. iOS, though, for the most part, an iPhone 4 and above or an iPad 2 and above, you're pretty much going to be getting, between 30 to 60 frames a second. The one thing that you lose, though, is sound, like I'd mentioned before, but the game runs incredibly fast. Then there's web markets, such as like the Chrome Web Store and Mozilla's soon-to-be-released Web Store. So you can also package up your game and then distribute it through these web markets. iOS native, so Impact also comes with an Xcode project, and the cool thing about this Xcode project is that it allows you to dump your game into it and then run it at basically like a native application. And what happens is that Dominic, who wrote Impact, created a wrapper that will just emulate Canvas and pass it through hardware acceleration. So you don't have a real DOM or any of the HTML elements. You just have this GPU-accelerated Canvas wrapper, and your game should just run as is. And then you have solutions like native WebView wrappers, such as Cocoon.js, which I highly suggest checking out. It's the same kind of concept as the Xcode project I was talking about, but it runs on Android, so you can actually package your game up with Cocoon and get 60 frames a second on Android devices, which is incredible. AppMobi has a solution as well for this. And then you get into like another tier, which would be PhoneGap. And if you wanted to distribute it on OS X, you can just build an OS X app with a web view inside of it. And then finally, the one that's got me the most excited is really the Windows 8 platform. And what's cool about Windows 8 now is that with Metro apps are just HTML5 and JavaScript apps. So you can take your game, wrap them up in a Metro app, and then have a native. You can have a native game running on Windows 8 in no time. And IE10 has hardware accelerated Canvas, audio tag support. It's incredibly powerful, and I think it's going to be really big if you're looking for a new distribution model for HTML5 games. So that was trying to cram in an entire game framework in 40 minutes. I'll cover a few games and just kind of the experiments I've been doing. Unfortunately, I'm not going to show them through the live stream because they probably run really choppy and crappy, but I have a URL for each of them. I'll talk about one of the first games I built, which is called Alone, and I built this for this 48-hour game jam called the Laudum Dare. This is actually Laudum Dare 22, and I highly suggest checking out these game contests. I mean, it's really hard to build a game in 48 hours, but it really pushes you to think kind of outside of the box. And Alone, what they do is they give you a theme for each game. So in this case, Alone was created during my first Laudum Dare competition, and the game is built around an Edgar Allan poem, and it's devoid of any visuals except for the world itself, so that it lets the player kind of imagine what's going on. And the theme obviously was alone, which is why I named it Alone. So this is a few screenshots of the game. So as you start out, you kind of fall down onto these words, and each of the words is the poem. And you'll see I have these snow particles and dust effect. I was very inspired by an indie game called Limbo, and this is kind of like my 8-bit version of Limbo, but with words. And you walk around this whole world, and as you interact with things or you get near things, so in this case, the spring has a little bubbling fountain. When you get to weapons and stuff, they have glow and fire that comes off them. And I was just playing around with these little particles. And then the way that I did all this is that I built these big sprite sheets that represented all the text, and I just put them down tile by tile. and then I went in and just mapped out the flow of the level, and these red boxes represent the collision layer. So I just map out where the player can stand. So things like this text over here on the right where I have not been seen, the player can never get to it since there's no jump. Therefore, I don't put any collision detection on it. And it's an important thing to remember. In the web browser, these things run really fast. But when it comes to mobile devices, you want to be very careful about what you throw at it. So try to optimize as much as possible. And then here are just some examples of these red boxes represent the particle emitters. So I can change the size of them and where they, how big they are and where particles come out and the number of particles they emit. So then I started, really kind of getting obsessed with these notions of, all right, well, I should really be building games faster. So I started building this game, Jetroid, which started out as a 2-week game and has now become like a 3-month game. But I built it in 2 weeks, just as a quick prototype. And the idea behind it is it's a very scaled-down kind of version of Metroid, where you land on this planet and you explore for life forms and artifacts, and you're trying to make it back to your ship before you run out of air. And as you explore the caverns on the ground, you start finding power-ups, and you're always fighting this battle of you have a jetpack, and if you use your jetpack, you start running out of energy. And if you don't have enough energy, you can't get back out to the surface. And all my games are on my my game website, which is gamecook.com, if you want to play along at home. And these are some screenshots of the early prototype that I built in 2 weeks. So I have this very basic ray tracing lighting system, which I didn't like at all. But as you walk around, it kind of illuminates where you are. And this is the main player, and you have to fly out at the exit, and you see the health, the power, and the air at the top. And one of the cool things is that I'm auto-generating the level. So I really love these kind of algorithms that generate mazes. So I took one that represented a rogue game, which is more of a dungeon crawler. And I figured, okay, a real cheap way to get around the fact is, that there's these big, long hallways, and I'm doing it as a side scroller is to give the player a jetpack. So that actually kind of working out really well in the game. And as I just go through some of these screenshots, you kind of walk around, and as you explore, it shows you, it kind of grays out where you've been, so you can kind of keep a reference to it. And that screen on the right is from the debugger inside of Impact, so I don't have the mini-map built in yet. And then if you run out of air, you suffocate and you die, and he explodes into little bits and pieces, and then you can start all over again. But as I started iterating through the game, I started seeing that, there's a lot better ways that I can handle lighting, and I was really worried about how to do the lighting. So then I just realized if I just do a transparent PNG on top of the player, what will happen is I get this really nice lighting effect, and I don't have any performance issues at all. So I went back through and started refining it, and now I'm working with an artist in order to redo all the graphics and reskin it. So I have a few screenshots here of the next version of this game and trying to make it look a little bit more cute and approachable for people. But here's just the player animations. Here are some of the monsters and the aliens that you can collect as you're going through the maze. And then also these are kind of the items that you pick up. You're looking for treasure. You're looking for these power-ups like air and health and energy to refill your meters. And, this is the direction that I'm going with this game. So I'm in the process of rebuilding that right now. The last game I'll talk about is Resident Raver. And this is the game that I kind of talk about building in my Impact book. And this was a funny idea that we had in college when I went to Florida State. The idea is that Resident Raver is kind of like this mix between Super Crate Box meets Elevator Action. And the whole story behind Resident Raver is that the entire dorm was turned into Raver zombies, and you had to escape this dorm. So each level of the game is a different dorm at FSU. And, it's always important to have like a nice big shot of yourself in the front of the game, to boost your ego. And from there, it's pretty straightforward game. You can kind of go up and down just like if you're familiar with Elevator Action. And zombies just fall from the top of the game and are constantly moving their way down the level. And it can set up, there's barriers and boxes that are around the level to kind of, bottleneck the flow of the zombies, and they can break them over time. And each, time you enter a door, you get a new weapon, and then new doors just pop up randomly around the level. But what was cool about this, this is kind of the modified version of it in the book. But in the book, I talk a lot about playing around with particle effects and these kind of cheap effects that we used to, see in 8-bit games, where in this case here, you wind up having the player I didn't want to do death animations because it's really kind of painful to have to animate all that stuff, so I just make him explode into little pieces of like pixel blood. And I always loved that in Mortal Kombat. If you like did a fatality, it was like 8 legs popped out and like 2 heads and like all kinds of crazy body parts. And then also the same thing in the bottom here, you'll see the grenade. So the grenade has the same type of particle effect. So once you start building out these effects, you're able to kind of reuse them all over the place and get away with some pretty cheap effects that look good. And another part about when I build these games, I sit down and I try to draw out the levels and then implement them. I don't just go in without a plan. So here's a sketch of one of the levels and trying to work out the flow in my head of how the zombies will actually move down the level, and then how I actually implement it in the level editor. And here's a screenshot from the level editor itself. Weltmeister is incredibly powerful. It allows you to also build relationships between entities. So you'll see all these white lines that are coming down from that blue box at the top. The way that I've set this up is that blue box is a spawner that locks and unlocks doors, and I've tied it to each one of these doors. And then that green bar at the bottom is this entity that simply watches for anything that falls to the floor and kills it. The purple boxes that are in the line with the elevator, that tells the elevator what floor to stop on. So you can do some really incredible things. And another thing that I did in the upper left is I have a little entity called settings. In the level editor, you can apply properties to basically any entity in the game. So I have like an empty entity that just has settings for the level. So instead of having to write a lot of logic and change the data, the format of the level itself, I'll just use an entity, and then when the game loads up, I'll pull that entity out by name, where I'll look for get entity by name settings, and I can get all the properties for the level. So if I want a level to just have 3 types of guns or have different types of zombies, I can do that in the level editor and just kind of think out of the box for it. So those were kind of the 3 games that I've been working on for the past few months. And this all led me to the fact that, while Impact is incredibly powerful, if you're coming at it from, not having a game background, or you want to just build things, really quickly, it doesn't come with things out of the box. There is no notion of a player or a camera and stuff like that. So I've been working on what I call Impact Bootstrap. And this is an open source project. It's hosted on GitHub right now. I just pushed a new version of it out last night. And it's still very alpha. I'm still working on it. But what I've been doing is taking all these games that I've built over the past few months and sort of breaking them down into reusable pieces so that anyone can just download this Bootstrap, add your own version of Impact, and then all of a sudden you have access to having a camera, having particle effects, having a player that can manage inventory, having pause screens, and all the stuff that kind of isn't built into Impact. So if you really want to start checking out kind of some way more advanced ways of structuring your code in Impact, I would highly suggest checking out my Bootstrap. And I'm going to continue to keep adding games to it, and it's sort of well documented at the bottom, talking about how to get it up and running. But this will also give you an idea of how to build a player and how to build a camera class and how to build plugins for the game engine. So with all of that said is the part where I pimp my book, but I wrote a book for O'Reilly, which is also why I'm doing this talk today. And I think it's the deal of the day, so I think it's like $6 or something like that. So it's 100 pages. I wanted to write a very concise book. And the idea is that you just build a game from beginning to end. I talk about all the automation. You get all the code examples for a basic game of Resident Raver. It talks about switching levels and all this kind of stuff that you would, want to do building your own game, especially stuff like setting up the camera and how to follow the player with a camera. So it's a very quick read, and I think this plus Impact would put you in a very good place to start actually building HTML5 games. And there's a lot of really cool things going on right now in this space. Even if you don't do gaming in your day job, there are so many times I built Flash projects that used game engines and used blitting engines to just get around graphics performance. I think we're going to see a lot of stuff start evolving with Canvas in HTML5, and taking a look at Impact and how it handles rendering the canvas would probably be a very good place for you to also look at, like, if you're building some sort of rich multimedia type, I don't think multimedia even is applicable anymore, but some sort of rich type app on the web now, and you're using HTML5 and you have access to Canvas, you can get away with so many great visual effects with that. So game engines are a pretty good place to get familiar with that, and also have a little bit of fun making games on the side. And the last slide, I just want to thank everyone for watching. And this is just a link to my portfolio. I've been posting a lot of articles lately about running Impact on Windows 8, about automating Impact using Ant, and also just kind of my talks about HTML5 gaming and where I see things kind of going. And then if you're interested in some, I've been doing workshops and also talks on it. So, if you'd like to see me speak about this in person, that's the best place to get, to get information on where I'll be next. Also, my games are at gamecooked.com. All of them are pretty much open source, and it's not just HTML5 games. I have my old Flash games up there as well. I have a Windows Phone 7 game. So, I just keep putting as much stuff as I can up there. And then you can follow me on Twitter, and I have a GitHub repo, which is Jesse Freeman. And my game-specific GitHub repo you can get, I think, through Jesse Freeman, which is just GameCook. So it's github.com/GameCook. And, I want to thank everyone for taking the time out to watch, and I guess I can start going through the questions now.
Great, Jesse. We do have several questions, as you can imagine, that have come in. Are you able to see them?
Yeah, let me just hit refresh. And, oh, yeah, hey, there's a lot of questions coming in. Okay, so I guess I'll just start from the top. So Daniel asks, using the framework in a mobile device, is it possible to get access to any kind of local storage like WebSQL? Yes. Since you're building a mobile game, we'll take it in two steps, right? The first part is that if you're building a mobile game and you're using a web view as your wrapper, then you have access to everything that web view gives you. And even in my online games, for saving score and experience, when I unlock different levels, based on how many zombies you kill and stuff, I'm using local storage in the browser. The place where that doesn't work is if you're using Impact's Xcode project. There's only a very small subset of things written for the native iOS wrapper, but I think the other wrappers that are out there right now, such as Cocoon.js and AppMobi, give you access to that local storage stuff. And actually, now that I think about it, let me correct that. The Xcode project does give you access to local storage for the native game, so you can use that as well. So yes, you can use. I just don't think you can use Web SQL, but like all JavaScript things, like you should definitely test what that browser or what your wrapper can support, and then try to build something like that. There's a really good plugin on the Impact forum for someone who wrote like a local storage class for Impact. And you can use I'm trying to think what the other one is. Lawnchair, I think, is the one I was using as well. So let's get to the next one. Cassandra, what all do you need to know in order to create a game? HTML5, obviously, but what else without using Flash? So the things that you probably should, be familiar with is JavaScript. JavaScript, everything is written in JavaScript, so that's the main language for building these games. Outside of that, I think, I do another part of this talk, which is more about game theory and understanding game development and how to approach game design. And I think what people really forget is that they want to build a game, and they think they can build a game and it's really easy, and building a game is incredibly hard. So in addition to just understanding JavaScript, and if you follow like the examples in my book, you don't really have to have a very good knowledge of JavaScript. You can kind of follow it, code by code. I break it up into small pieces for people, and then over time you'll just learn how to get better at JavaScript. But I think that really studying a lot of stuff like game design and looking at how people make games would probably be the most beneficial, because that is the skill that will allow you to take it from one platform to another platform. In 5 years or 10 years when HTML6 or something else comes out that's even better, you want to, if you really want to build games, focus on being a good game designer. Okay, let's see. Oops. Let's see. The next one is, so Justin asked, does HTML5 support 2D or 3D for real-time strategy games? So Impact is just for 2D. You can get 3D, you can get hardware acceleration for Canvas, but you can't actually do 3D in it. So it doesn't do anything for like WebGL. And I think right now in the HTML5 gaming space, that's a real weird place is the 3D world of it, because WebGL is supported on all the WebKit browsers and Firefox, but not on IE. So I haven't played too much around in that space until it kind of, sort of levels out. But it's definitely geared towards 2D games, with the sprite sheets. But you could easily do a real-time strategy game with it. And in fact, if you look back, most of the real-time strategy games that started the genre, like Command and Conquer and Warcraft, those were all 2D sprite-based games to begin with. So I think that would actually, you can easily do that. I think the real question is going to be the scalability and how large you can make the maps and how efficient the AI would be. So the next question is, Chris asks, can assets be dynamically generated and loaded into the game ad hoc? The answer to that is yes. So you can, a good technique, and it's actually used inside of the game engine itself, is to create a canvas off to the side and, off of the display, draw anything you need to that canvas and then get that bitmap data, and then you can use it and access it within your own entity, and then you can put that inside of the animation sheet or an image wrapper. So, in Impact, what you wind up doing when you create a game is you can actually set the scale for the game itself. So since I'm doing pixel art at 16 by 16 pixels, I usually put it up to like a scale of 4 so that it actually looks like a decent size on a computer. The way that Impact does that is it'll take all the graphics that you give it, and it resizes everything on the fly before the game starts, and then it just uses those resized images. So most definitely you can do that. It would just take a little bit more work. There's a few helper functions to get access to a new canvas inside of Impact, but it's not like it's not built in a way that would be somewhat intuitive if you didn't dig through the source code. Let's get to the next question. Would be Pablo asks, could support BlackBerry Playbook WebKit browser? Yes, I've heard that people have run it on the BlackBerry. From what I've heard, it has a pretty decent implementation of a WebKit browser. I would not know about the audio, but any WebKit browser, I said honestly, in any browser that has Canvas, you should be able to run the game on. It just really comes down to the platform and how fast that Canvas rendering is. Okay, Eric asks, under iOS native, does the sound limitation exist as well? Okay, so in the Xcode project, there are actually wrappers to native iOS sound pointers. So what you can do is when it loads up, you actually supply, is it AIF or ACC? You supply the iOS sound file, and Impact will automatically load that iOS sound file for you, and then you can get full sound. So there's no limitation in the native one. You just have to supply the correct sound format. And I do talk about that in my book, and it's definitely on the website as well for Impact. So Sharon asks, any suggestions for retrieving info from a backend database and displaying the info on the sprite? Say a player or a team name that will move along with the sprite. This is just JavaScript at the end of the day, right? So whatever you can do to connect things up in JavaScript, you can also do. That's kind of why I'd say using Node as a backend. I think that's probably going to be where a lot of multiplayer type servers are built. You can use WebSockets and all the normal things you get from regular just HTML and JavaScript in modern browsers. And then, on the actual implementation route, it's just as simple as creating a font inside of your entity, and then on your entity's draw loop, just have the font draw whatever that player's name is on top of it. So you can do that stuff dynamically. The one thing, though, I would point out with fonts and Impact is that there's an incredible performance penalty for using them because each character is drawn on its own. There's no way of actually caching it. It's the one thing I'm looking into in my own text field is you have to actually, so a font with a lot of characters in it is going to, if you have a lot of these characters all over the place, it's going to slow the game down. So fonts are a little bit expensive, so I try to avoid that. where possible, or use that technique I was talking about where, and this is kind of what I want to do with my own stuff, is have the font generate itself to a canvas off the screen, and then take that graphic and put it back in and just use that cached image so that you only get one draw call instead of one for each of the characters. So Scott asks, is there support for create sprite sheets using ZWOPTEX? I am not familiar with what that is, so I can look that up and try to figure that out at another point. Let me see, what is it's a sprite sheet generator in a couple of clicks. I would imagine that Impact is going to have a problem. Oh, I have seen this. This sprite sheet application is spelled ZWOPTEX, and it's at its own website.com. And it looks like just a bundler. I think the problem that you would run into with this is the atlas that it creates. So generally these sprite packagers try to put all the sprites in the same, as close together as possible, and they're not easily divisible. So Impact definitely relies on the rule that all the sprites are a consistent size. They have to be 16 by 16 or 25 by 25, and then you set the width and the height, and then you can pull it up by an index. You could probably patch Impact to load this up. I'm sure that this application will output the atlas, and but you'd have to do that manually. So you could add that support yourself if you wanted to. James asks, I'd like to hear more brainstorming ideas or examples on how to apply gaming ideas can legitimately spice up non-gaming sites. I don't have a lot of time to get into that specifically, but some example sites that I talk about that I did in my talk at Fluent. If you look at HBO.com, the schedule for HBO.com is actually a blitting engine. I wrote this blitting engine in Flash, and it renders out the entire schedule as almost like sprites, and they're sprites in the sense of bitmap data, not the sprite class in Flash. And then also to handle the scrolling and everything, there's a game loop that runs it, and I use that game loop in order to synchronize my easing equations and everything. So that's one example of where I wrote a blitting engine inside of, or a game engine basically inside of an enterprise application. And other examples is anywhere where you have really rich visuals and you need animation, having some sort of notion of a game loop or timer or synchronization and the things that you learn about animation inside of game loops will help your application. An old framework that I wrote in Flash called Flash Camo also used gaming concepts like skinning buttons through sprites and stuff like that. So those are kind of a few examples of how I apply gaming concepts to enterprise apps. Let's see the next question. Cassandra, where would I find your lecture on game theory, or on gamecook.com? I believe on my, in the book, I have a chapter on game theory, and I go through kind of what in most of my talks I took the material from the book. So I guess not to push my book, but I guess the best way would be to, if you read my book, there's one chapter just on game design. I talk about some good books as reference. I also have an example of a game design document, which is usually a big document you put together that outlines how a game would work and its graphics and all that stuff. I would check that out, but then it's like a 15-page game design document of a full game that I've been working on. I think we're at the last two questions. Okay, so Scott asks, does Impact support any sprite packaging tool and format such as texture packer? Yeah, so that would go back to the other question about that other tool. It only supports easily divisible sprites. Like I said, you can patch Impact to support that, but you'd have to do the work on your own. Actually, let me hit refresh because I think there might be more than that. Nope, I think we are at the last question. All right, Jonathan asks, can you compare Impact.js to Coco's 2DX HTML5 features? That, unfortunately, I cannot. Coco's 2D has been on my list for a very long time to check out. I I don't know enough about the framework to compare the two, but I would have a feeling that if Cocos 2D is doing an HTML5 output, it might be pretty robust and it might be a pretty interesting thing to look into. So I'll have to add that to my list of things to check out, but that is a good thing to bring up. So I know that Cocos just did a new C++ implementation for Windows 8 as well, and a lot of people are using that for cross-platform game development. So that might be a viable option as well. I think that is all of the questions. Let me hit refresh and just make sure. Yep, I think that is it. So thank you, everyone. Sorry we went over a little bit, but hopefully everyone found it, entertaining. And I'm pretty easy to hit up on Twitter. And if you do pick up the book and you play around with Impact, hope you enjoy it. It's been a lot of fun. It's probably been one of the most fun things I've been doing in HTML5 lately.